All right, so you can hear me guys now? Let's go. Thank you guys for joining. I really appreciate making it thus far. As you can see, probably we gotta discuss my CISO perspective on laws, compliance, and data privacy regulations in the cybersecurity space. So as I mentioned, we gotta discuss laws, compliance, and regulations. So I'm gonna provide my CISO perspective. But of course, you've seen a meme next. And hold on a second, this is not actually about laws. So for all the people who have left, thank you so much. This is actually about Pwning Cloud Contexts. I'm going to share a hacker story on how I went from a Github token access to compromising a whole GCP organization. What am I? A little introduction. My name is Ayoub Fathi. I go by the same on Twitter. I work as the Group Vice President of Security at Noon. It's the leading e-commerce company in the Middle East. I'm a hacker by heart. Basically, prior to Noon, I was hacking a lot in the bad bounty. I was going to live hacking events. But after that, I joined Noon. Before Noon, actually, I was also running some businesses. But I'm also passionate about business, software engineering, cybersecurity, and everything in between. So how this is started, actually, Nikhil reached out to me on Twitter. He reached out to me 6 months ago on April. So usually, what other speakers do 6 months before an event, they probably have a 10th version of their slides, and they probably wrote a lot of code to release some tools probably for the event. What I thought I would be doing too 6 months ago was actually also writing a lot of code and preparing slides. What I was actually doing at the time is 4 days before the event, I dropped 99 commits on a Saturday, and I was just taking the first screenshots from my slides, and I was working still on it on the flight on my way to B-sides. So yeah, that was how I got into this event. So why this talk matters? I have 3 reasons basically. First reason is there's public GitHub leaks. I'm sure enough of you guys are familiar with it. The problem around this is so many people actually are unaware of the true risks of GCP token leaks, or any token leaks generally. So they report it to programs, and they don't manage to escalate or kind of improve the impacts of the reports. So the second reason I want to discuss this today is I hacked into so many cloud organizations, and the reason is because they have all the cloud providers are built in a way that is the IAM system, which is responsible for roles and permission, is so broken in such a way that it makes it easier for organizations to make mistakes. And as a result of that, you can see there's a study from Google actually. It says 99 of cloud users, they're granted excessive permission. And what this means for you guys, probably if you are bug hunting, it means if you land on a token, it's probably highly privileged already, or you have a way to make it highly privileged. I even mentioned that on a tweet where I was if you just create a new project on GCP, you add someone to that project, you don't give him any access, he already have access to Cloud Vision API, even if you don't give him any access, which is crazy to me at least. There's even another study from that Google actually have shared. It says 60%, which is 2344, 60% plus of the confirmed token leaks on GitHub were actually equivalent of super admin and admin access, which means there is a 60% chance you land on a highly privileged account on GitHub. The third reason I want to discuss this today, if you have a GitHub access to repositories for some, some organization, there's a very high chance this token can actually lead to accessing the cloud as well. And it's mostly through OAuth token exfiltration, which is the main theme of our discussion today. So I'm going to also discuss with you guys many ways you can hunt for GCP OAuth tokens. There are so many techniques. I'm going to share my stories, some reports, how I did that exactly. There are some terms I'm going to use interchangeably this talk, which is, there are some cloud terms that may seem complicated to understand. I'm just going to translate them into kind of bug hunting terms. So project ID on GCP, think of it as a project name. Service account email is just an email or an account. Account impersonation is basically account takeover. So if you just think of them this way, it's going to be much easier to understand. So now let's go to story time. I'm going to discuss, guys, how we went from a GitHub token to compromising an entire production GCP cloud organization. There are 2 disclaimers to make here. First, I have recreated a whole lab because I'm not allowed to share the target in any identifiable way, directly or indirectly. So I have recreated a whole lab. I'm going to share all the POCs from that lab. Second, all the post-exploitation techniques we're going to discuss today, you always need program permission to proceed with them. So please don't just try to escalate your access without checking with the program. The timeline for the story is like this. So we're going to start with a GitHub token leak. We're going to go and exfiltrate a GCP OAuth token, and then we're going to run a privilege escalation to the staging projects. We're going to jump to UAT, and then a lateral movement to production. And then we're going to compromise the GCP organization. So that was like the finding I came across, and this is the flow I followed myself. Actually, I created a visual. Guys, you have no idea how much time it took me. Like, the reason I had to do this because there's like so many requests and burp suite, like you guys are going to get lost if we don't have like a proper visual for it. So we have like 5 phases of the attack. We start from GitHub, we jump to a staging project, then we jump to a UAT project, then we compromise production, then we have like the whole organization taken over. So now we're going to enter phase 1, which is the OAuth token exfiltration. As usual, it always starts with a Slack notification about like the token leaks. So I have this channel, I get reports on so many bug bounty targets. And some of you guys know I run like so many automation. Part of it is one of the tools that runs and monitor GitHub for token leaks. I'm going to show you guys by the end of the talk how I'm doing that exactly. This tool is running every 10 minutes. So, you got to be so quick because otherwise some people would actually find this before you do. So, the best part, this is actually costing me $0 to run on GCP. And I think that's a whole different talk to discuss how we do it exactly, but it's just like choosing the right products on GCP. So back to the token leak, we got this notification, we check it out, it's a GitHub token, gives you access to run API calls to GitHub for some victim account. Then I use the CLI to use that token. I'm using here the lab I mentioned. So then we use the CLI, we access the account. Then we list the repositories this token has access to. We can see it has access to besides build staging repository. Then I'm just going to go and clone that and list all the files. We can see clearly there is a cloud build YAML file. Before discussing how we're going to maliciously exploit that, we're just going to discuss this cloud build because it's very important. So cloud build generally on GCP, but like cloud providers, it's a process where you push code to GitHub. There is a build on the cloud that picks it up, and it builds a Docker image for it, and it stores it on the cloud. So basically, whenever someone pushes a code to GitHub, there is a Docker image being generated for that. Now, the interesting part is how we can exploit that. I decided to add a bash script, a malicious script. You can see, guys, clearly that it's calling the metadata API, and it fetches a token, it pipes it to an attacker-controlled server, but we can't actually have this running without doing something else. We can just add the script and push it to the victim account, and then we get a token. Usually, you have to also edit the cloud build YAML file, which we discussed earlier. This is the glue between GCP and GitHub. It's the part that whenever you push a code, it builds a Docker image for it. So we now inject the scripts we have created at the beginning of this. And the reason we do that is because we want it to run first thing when the build process starts. So to summarize, we added that malicious script, we injected it in the cloud build YAML file. Now we're going to just go ahead and push our code changes and push them to GitHub so that the build process triggers. If you want to see, if you have access to the UI, this is how the changes are going to look like. You want to push it to a random branch, not the main one, because the organization would probably notice. If it's on a random branch, no one would actually notice. So once we push our code, it's going to run right there in this exfiltration OAuth access token, because it triggers the build tries to build the Docker image, and then it's going to run our scripts first. And after that, we get an access token. And what we can do with access token, we can take it, start calling GCP APIs to do further things with it. So one thing to note here is once we get the access token, it actually expires within 1 hour. So you want to every time start doing another commit to ping again, such that the build triggers again, and you get the access token again. You get a fresh access token every time. So yeah, that's a recap for phase 1. We started with the Slack notification. We used the GitHub to actually clone the repo. We pushed a malicious code. It got actually built. The build process was running on the staging cloud organization, and we exfiltrated an access token for GCP that we can use later. Now entering phase 2, OAuth privilege escalation. So now that we have like a GCP OAuth token, which is it does belong to GCP, there is actually a lot that we can do from here. And as a first attempt, I'm just gonna go and ask Google, what is this token? Like, who is this token? There is kind of a who am I API we can call. It's user info. You can just ping that, give it the token you have, and it's gonna say, hey, I'm project member at Cloud Build. And I'm gonna, guys, start labeling accounts like this, because we're gonna use so many tokens and you're gonna get lost if I don't do it this way. So now all we know is the token belongs to this account that starts with project name as Cloud Build. Next, the question is, if I have this token now, what is the access it has actually? Like, what kind of access it has, what we can do with it? There is an API for that, where you can ask Google which access this account has. But the problem with this API, it requires a project name, and we don't have the project name, right? We only have, if you remember, the project number, which is the beginning of the account we exfiltrated. So how we can use the project number to get the project name? Also, there is an API for that on Google Cloud. You can call this first API, you get the project name, you add it to the second API, and then you get the user permissions. So this is what we're gonna do next. We're just gonna call using the project number. You can see we get the project name. Then we can take that project name, supply it to the next API to get what is the roles or permissions of the exfiltrated account. But I wish life was that easy. Unfortunately, we get permission denied, because simply the token we have access to doesn't have permission to do that. So what is the next attempt? Like, what we gonna do next? So now we're gonna try a different path. The second attempt is GCP actually has an interesting feature. I mean, a very interesting one, especially for you guys. It's called service account impersonation. And you want to think of this in the perspective of like bug hunting as taking over accounts. You know, in GCP, if you have one of the permissions, which is not considered like super high privileged, if you have like a permission called token creator role, you can decide to take over any account you want. It may seem crazy to you guys, because it is the case. I mean, most cloud providers provide that. There's a permission that allows you to take over any account on your project. So service account A can start acting on behalf of service account B to do things on cloud, basically, which means if our limited access service account A cannot do some actions on GCP, but it can actually take over account with high privileges that can do that, you know? So running with this, there are like also a bunch of other permissions that allow you to do that. I call this like a privilege escalation by design in most cloud organizations. So if you guys get any token on GCP or AWS, you should know like most of the cases you can escalate your access. So a data checkpoint, I just want to revise what we did like so far. We have a project number, which is the first bit of the account we managed to exfiltrate. Remember, coming from Github. We have a project name besides staging, and we have an org ID. So the question now, what can we do with this kind of information? There is some information we know about GCP, which is you can take a project number and predict that other accounts exist. So I just can go and say, actually, compute developer account exists. These are called default service accounts. And why I want to do that is the question. Why do I want to create or construct these accounts? Because actually, if you guys remember, the feature we discussed on GCP, which allows you to take over other accounts, I want to be able to use my limited account that I exfiltrated to jump to these other accounts. But the question is, if I want to jump from Cloud Build to Compute Developer, why do I want to do that? Because actually, I know a fact about GCP that this Compute Developer, most of the times, it has editor access. Editor access on GCP is like the equivalent of an admin access on anything else. So I have limited access. I'm trying to privilege escalate my access to editor, which is highly privileged. so that I can start like, calling these APIs. I don't get access denied. I don't get like other, 403 responses. So now we know this in theory. How we can do it in practice? What is the APIs we can call? What is the API we can call to say, I want to impersonate this account? So this is where the generate access token APIs comes very, very handy, because then you can call it. You can simply say, I wanna impersonate or take over this account. And you can use the exfiltrated token that we got earlier, and it's gonna give you the access token simply for the account you wanna take over. It works like that on GCP, which is, I don't know, it's crazy for me at least. Of course, you need some permissions, but they are not like crazy permissions. So now that we took this account, we have the access token for this account. What is the next steps, guys, we're gonna do? Simply, we're gonna copy it, start using it here, and we're gonna start acting on behalf of the target account. So first thing, I'm copying it and asking Google, who am I? What is this token? It belongs to whom? And it says, oh, you are compute developer. So you guys can see, we managed to escalate our access to compute developer. And compute developer, I know it has editor most of the times. Sometimes organizations change that. So I want to check. If you want to check what access the account we were able to impersonate has actually. You remember, we called this API earlier, we got access denied, right? I think now we have a highly privileged token that we can use, and it just works. You get all the accounts within the Sagent project. So now I just want to know what is the permission that my token has, which is compute developer. You guys can see it has editor, as I mentioned. It's by default in GCP, but sometimes people change it. So we just double checked. It has editor. I feel that's a success because we managed to go from a lower tier access to escalate our privileges to editor access, which is really highly privileged. So we authenticated as compute developer, remember, coming from the exfiltrated token. And then we have editor access. Editor access has more than 7,000 permissions. It's crazy number of permissions. You can do pretty much everything on a project. So yeah, we basically compromised Sagent. That's like phase 1. So to recap the phase 2, if you remember, guys, we started from a GitHub access. Started from a Slack notification, GitHub token. We created a malicious script. It was triggered. We exfiltrated the token. Now we managed to account take over another email or like another account on the Sagent project, which is highly privileged, and we compromised Sagent. Basically, now we are entering phase 3. Lateral movement from Sagent to UAT. So now remember, guys, we are inside Sagent, but not with the first account we started with, but with another account that we've taken over. We call it on GCP impersonation, that we have impersonated. So now the question is, we are inside Sagent and we have editor access. What can we do more? That's the first question you have. So if you guys remember, our project is named as Besides Sagent, right? Does that ring any bell for you guys? I mean, the first question for me at least is, if there is Sagent, probably there is prod, probably there is dev, probably there is so many other projects. How can we move to these other projects is another question. But like the first question I have is, does our exfiltrated token or the token we've taken over have access to all these projects? I mean, that's the first question that we need to answer. But like an even more important question, what if this account doesn't have access to these projects? Can we find another way? Yes, we can, because you guys remember, we can take over other accounts that may have access to these projects. And this is what we're gonna do. We're gonna take every other account we can impersonate or take over and try accessing other projects. So before that, let's chat about something. There's a notion called cross-project service accounts on GCP. And how it works is, you may have two projects, A and B, and the accounts created on A actually may have access to B. It's a feature, by the way, it's not a bug. Like, project B may decide to give access to an account in A to do something, So at any given point of time, you may have project A or like account A with access to two projects or more. And that's an interesting feature because it brings me to the question of, like, what is the other GCP project that my exfiltrated token can have access to, or the ones I can take over can have access to. So now we need to answer this question. So far, our reconnaissance on the project, we have a Sagen account, we listed the other accounts, but we don't know which account that may have access to other projects, right? And this is the next question we want to figure out. So we don't know how to do that, but there is only one way to do it. It's bridge forcing. As simple as it is, this way we can do like bridge forcing. I personally call it lateral movement bridge forcing. So we can use this. If you guys remember, we have a way to take over other accounts, right? How we can take this methodology of taking over other accounts and then bridge forcing our way to other projects. This is the lateral movement bridge forcing. So I created this diagram to make it clear for you guys. So we started with Cloud Build, right? So remember, we have the exfiltrated token. This is the exfiltrated token. We can go ahead, take over all the accounts on Sagen, and we can start asking production, hey, production, can I send you an API request? If we get to 200, we have access. If you don't get to 200 or like access denied, we don't have access. It's as simple as that. So, but the problem is, now we are talking about one project. How we can bridge force this way, like through so many projects, especially that we don't know the names of the projects. I'm just gonna provide it a word list, right? But the problem, if you wanna do this process manually, you're gonna end up with like 200 tabs on Burp Suite, which I did actually. I'm gonna show you guys I automated this process, but like this is only I've done it for the lab. But I personally, when I was reporting this issue to the targets program, I did all that manually, and this is crazy. You don't wanna do it actually. So now we want to create a script to automate this. So after 4 Red Bulls and 150 tabs on repeater and 99 commits later, I just decided to write some code for it. And if we're going to run this, you guys can see there's always a Sagen project going to our target projects. And what it does is exactly what I showed you in the diagram. It just targets all these Sagen accounts, take over them, and send API requests to the target project. So that's literally what's happening behind the scenes. I'm just taking accounts, sending API requests. If I get access denied, that's access denied. If I get access, I'm going to flag it here. So yeah, as I mentioned, this is what we did. But remember, we are not trying it only on production. We're trying it on a word list. And this is the way we're going to do it, which is the exfiltrated token is going to impersonate or take over other accounts because we have the access to do that. And then I'm gonna take all the access token for these target accounts, try them on targets projects. If anything returns 200, I'm fine with that. You know, we have access basically. So we've done it again from Sagen to production. We have no access. We've done it again from Sagen to UAT, and we have access. So I found this account. You guys have no idea how many repeater tabs I have to do to actually run this manually. So now that we have this account, you know, we have the Cloud Run provisioning account. What this means is the script is telling us, hey, you can actually start from your exfiltrated token. You can try impersonating or taking over this account, and it's going to allow you to access UAT. So that's what it says basically. So now that we have access to Sagen, from Sagen to UAT through this account, which is cloud provisioning, I'm just going to go and directly target that. And I'm going to create an access token for it, using the API I showed you guys earlier, which returns to you an access token. Get the access token, start using it in API requests, move laterally to UAT, and then within UAT, I'm just going to list all the accounts. Do you guys know why I'm going to list all the accounts? Because again, I want to target them as well, and we're going to keep just doing that. So that's in theory, but how it looks like in practice in terms of API requests. So requesting an access token is basically that. The request I showed you guys earlier. You go, you provide it with the target service account you want to target, and it's going to give you back the access token for it, and we start using it. So then we use that here to list all the accounts in the target project, which is UAT. So guys, you can see now that we managed to access UAT, run operations on it with a Sagen account. So that's lateral movement. I call that a success again, because we managed to move from Sagen to UAT. So as a recap for phase 3, so we did lateral movements from Sagen to UAT, and again, we're coming from GitHub, exfiltrated the token, escalated our access to editor, then we listed all the accounts, and then we started lateral movements bridge forcing. We found one account that can actually push us to the UAT. So now we are entering phase 4. the same process again, lateral movement, but now from your AT to production. So the question becomes like, what is the other project you're going to access from your AT? It's the same question we asked earlier, right? From staging. So remember, we have this account. This account has access on staging. What we're going to do next is, again, lateral movement-based forcing. So impersonate all accounts, run API calls, success or failure, you decide which account has access. And this is just one project. We're going to do it on so many projects. This is basically what the script does. It just goes, run a loop on all the accounts, run a loop to send API requests, you get 200, you get 403. So I'm running the script now, but the target now is, you can see the original project is your AT, and I'm running the target projects as a wordless. So if you can see, we get Alpha Core Payments API, it actually has access to production. And again, knowing this information, I don't have to try every single API request manually. I can just go directly and create an access token for this account that actually the scripts have provided us, right? Create an access account for it, take the access token account, run it on production, list all the other accounts to do the same process basically. But like now, how that looks like in practice, we just create a token, right? We call the generate access token API for the target account on the path. We get that token, we copy it, we use it next. We list all the accounts. And you can see, guys, that we are repeating the same process. I call that a success again because we managed to move to production. So a recap for phase 4 is literally repeating the phase 3 process, but this time we move to production. The question now becomes is, if you have production access, what kind of other access you would seek, right? There is actually a higher access than production, which we're going to discuss, which is org level. If you know like GCP, if you have org level access, you simply have access to all the projects. So I'm not going to then target, which project am I going to move to? I'm just going to go and say, if I have org access level, I can do anything across any projects. I can even, without having to brute force, I can even find the projects within the organization, right? So is there any higher access than production? Yes, there is. If you guys remember, these are the accounts we listed already in the production, right? So again, the same thing, but now for the org level. And what is the difference between org level and project level? It's just the APIs you are calling. I'm just going to go and say, the script is going to go and say, impersonate these accounts, start calling the org level permissions. Like I'm just going to go and say, hey, can I list all the accounts at the org level? And my token would say, you don't have access to do that. And then I'm going to say, I have no access, right? So we do that again, and we figure out which accounts have access. And you can see from besides prod, you can see I passed an argument, which is the org ID. We already have that. And we got the organization owned, right? So you have shared VPC account, and this has access at the org level. Video cannot be loaded, unfortunately. I have a POC for that, but it's not showing. I don't know why. But yeah, anyways, so now that the script is saying that, there is an account actually we can use to call APIs at the org level, I'm just going to do the same. Generate an access token for that account, get the access token, start using it, clone org level APIs, and we managed to get an owner actually. The account had an owner access. The targets I was working on, account had an owner access, and I can do literally everything on that organization. Like literally everything. That's a recap for phase 4. Phase 5, which is GCP organization compromise. And we managed to compromise the organization. As a recap for everything, if you guys remember, we started from GitHub. It's a GitHub token that was leaked publicly, right? It has nothing to do with GCP, right? How could actually say that this will give you access to GCP and you can compromise an organization? There is a lot about that stuff actually, and honestly, I have oversimplified it. You can do like more than that. It's much more complicated than you can do more than that. You can always escalate your access. As I mentioned, GCP is or AWS as well. Their rules and permissions, IAM systems, they are broken in a way that there is always excessive permissions on any account. So if you find accounts, you can always compromise them. So yeah, we started with a Slack notification. We pivoted to GitHub, pushed the malicious script. We exfiltrated a token. We had a privilege escalation to Git editor. listed all the accounts, run lateral movements, bridge forcing, found one account that pushes us to UAT, repeat the same process, production, repeat the same process, organization level, So, guys, now that you know like how to compromise GCP using an OAuth token, the most interesting question from my perspective is how to actually find those to begin with, right? Because now you understand that if you find that GCP OAuth token, you can almost always run privilege escalations, lateral movements. You can do so many things. So now, like, how to find them? I'm gonna share with you guys 5 different ways on how you can hunt for GCP OAuth tokens. And first of one of them is command injection. I mean, obviously, right? Like command injection, you can do so much, right? But the question is how to look for them. I see many people like they just run normal payloads. Actually, you can find patterns. Sometimes, like, I don't know, when I see, for example, a list within a string, that's a candidate for eval. People would run eval on that many times. If I see like a dictionary within a string, that's also another form to look for. Sometimes you would see function names within the value. Sometimes you would see object calls to classes. That's also something that could probably run behind eval. And these are like some patterns you could look for to actually try command injection payloads on, because they usually run behind eval, which is a straightforward command injection. I found that actually one of the targets. You can see, guys, it's a blind command injection because I was running the listener, I got the hit back, but then like, it doesn't show anything here, of course. So the payload was simply, I'm doing the same thing that we did in the GitHub scripts earlier, remember? I'm just calling the metadata API, but I'm piping that output and sending it to my attacker-controlled server. So this is how the request look like. Just simplifying it for you guys. There's a payments history API. Parameter. You just do OS system. You call the metadata, send it to your attacker server, and hallelujah, you get a ping back with a token. And you can take the token and do everything we did here. So that's a very good entry point to look for. I see so many times like people really underestimate fuzzing. So behind like looking just for pattern, you can fuzz your way to that stuff. You can just provide a word list with so many payload injection, command injection payloads and the SRF payloads, but like you can change that to your IP so that, and you run it on a target. And there is so many times you can get. So like, for example, the example I showed you guys earlier, you can find it with fuzzing. I even mentioned that on Twitter. I mentioned fuzzing API is so underrated. And I've seen many people, they don't take it seriously. And yeah, it's kind of awkward also to go to yourself, right? I'm now going to move to the second way to find OAuth tokens, which again can allow you to do all these privilege escalations, service account leaks on GitHub. You know why I believe this? Because I've seen so many organizations, they just give service accounts to all of their employees, and they have crazy access, and the chances one of them is going to push it to GitHub publicly is very high. So I told you guys, remember, I'm running this GitHub monitoring tool, and it actually consumes one of the databases on GCP. It's called FileStore. I'm just providing it a list of keywords. So it does the search and it scrapes GitHub and it looks for these keywords. And you can see here, of course, there's a snapshot. There's like PayPal, there's other things. Like there's so many targets. The list is huge. I'm just showing you an example. This is, for example, a signature to look for service accounts on GitHub. And the script is doing exactly that. And many times I found service account plain text on GitHub publicly. And you see, like, there is a signature. You can just look for it on GitHub. How you can, like, now once you find this account, this JSON file, how you can use it? You can simply call gcloud auth activate, provide the credentials. It's gonna give you access to that account. Then you can just print the access token. And again, as I mentioned, if you have the OAuth token, you can do everything we've done earlier, right? So even Google mentioned they have observed some customers leaking that stuff publicly. And there is so many attackers picking up that stuff very quickly, like on the spot. I mean, I tried this myself. I tried to put a token there and see how it's going to get used. And, that's why you got to be so quick. That's why I have the monitoring tool running every 10 minutes. Like, you got to be so quick to finding that stuff. The third story is like when SRF is meeting kernel injection. That's a wide story, at least from my perspective. The context behind this is, guys, if you want to call the metadata API on GCP, you always need to provide this metadata flavor. It wasn't the case a few years ago, like once upon a time, I've had instances where I found this, for example, like SSRF through a PDF parsing engine, and you can just pass V1 beta 1, right? And you can get the access token. Again, you can do everything with the access token. But unfortunately, Google have actually fixed that. They started requiring it now everywhere. So this is the context, but like there is something I've been fantasizing about since forever. It's a short story that never happened, and this breaks my heart. And the reason is, for example, when someone reported an SRF internally, first thing that comes to mind is this finding, which is, oh, there is a correlate injection in URL lib, right? So first thing I asked is, did we try correlate injection within the SRF? The idea is the following. So, I mentioned earlier, in a normal request to the metadata, you must add this header. So you cannot just send this request. You cannot get a hit back for the token just using this, right? So the idea is, how about we just put an correlate injection within an SRF, right? You just use like the new lines characters, and hopefully you want the request to be forwarded like that. So that's an epic fail. Unfortunately, even within the vulnerability I showed you guys, not only it was fixed in the library itself, but even Python version, most Python recent versions, they automatically have fixed that already. And yeah, because it's using HTTP client underneath. So it's solved in most Python versions, even if you have an old URL lib version. So yeah, that's, they never met. SRF and correlate injection. So that's the end of that story. The fourth way I'm going to share with you guys how to, of course, it's very hard, but like if you have compromised hosts, if you can access some machines, you can always echo this variable, which is going to give you exactly the location of the service account. And there are also like some SQLite caches for gcloud or GCP commands, where actually it caches the access tokens and the refresh tokens. You can always do all the dance, and you can always fetch a new access token. The fifth way, a lot of you guys know about JS leaks generally, but like, have you ever seen this? A service account in a JS file. This is why you guys should probably always monitor JS files. It's a treasure hunting kind of one of the best resources to find stuff. So yeah, these are like the 5 ways I wanted to share with you guys today. But hey, defenders, I didn't forget about you guys. How to minimize the risk of lateral movement. If you guys notice this conversation I've had with someone internally, you need to have proper alerting. So I have created a lot of alerting around that stuff, such that I've noticed one account, it was like really unusual. It has some unusual usage. And then I flagged it to our DevOps team, and they were like, oh, actually, that's just as we were testing. So if you have like proper alerting, you can always find that stuff if someone is trying to exploit it in your environment. But like even better than alerting, you need to have proper defense in depth. So this is where you need to ditch all the JSON key files. You don't want to have them. You could always use something called workload identity. Less privilege. So instead of giving anyone editor access or owner access, just create a custom role with very specific limited permissions and assign it to DevOps, assign it to developers, assign it to everyone. Of course, there's also dangerous permissions you should avoid. Look, if any of you guys are using GCP in your organization and you have editor, owner, viewer, you have a job to do right now before anything else. Like, this is something for me, it's a non-negotiable. Like, you should never, ever have in your organization anything that is editor, owner, viewer. That's a lazy way to do it, to be honest. So there are some other rules you want to avoid, but sometimes you can't avoid them. But like the first one, editor, viewer, owner, that's a non-negotiable. So yeah, now links and resources. Some of the tools I used in this talk, unfortunately, the disclaimer here is it's very customized to the use case I was working on. It's still buggy. I'm gonna share it with you guys. I'd be happy to share it, but like it's not gonna be. Don't expect it's gonna be work magically like for all the cases. So that's a disclaimer. The other one is Github monitor. I'd be happy to share it with you guys as well. So some helpful GCP APIs for reconnaissance. I'm gonna just attach them to these slides. I'm not gonna talk about them here. So I'm skipping this. And that was it, guys. Thank you very much. Yeah, let's start after that. We're on LinkedIn. Thank you, guys.